so the title for this experiment is called Thermodynamic Performance Evaluation of a Small-Scale Radial Gas Compressor and Turbine. Okay, so to put it simple, you are going to look at compressor and turbine used for gas application. Gas mean air, okay, not hydraulic. It's a small scale, and you are going to determine the thermodynamic performance. And therefore, because this is a thermal module. Okay, so compressor and turbine, when you heard these two words, what do you think of? Everyone taken apply thermodynamic? Everyone taken, right? Okay, so in the chapter 2 of your applied thermodynamic, you learn about gas turbine cycle, right? Just like the one seen here. Okay, so this a simple gas turbine cycle, right, running on gas. It consists of compressor, it consists of turbine. So these two components is what you'll be looking at, and you want to evaluate the thermodynamic performance of it. Okay, and these two components is a, if we are going to put it in the introduction form, is a typical force induction system. So it supply air flow to power plant and also internal combustion engine for combustion. So combustion chamber obviously is to combust, to produce power. Same goes for internal combustion engine, just like the engine in your car. So compressor is a device used to supply air. It's powered by turbine, as you learn in your applied thermal. Okay, and turbine is the one that recover the energy from the exhaust gas. It takes the heat energy from the exhaust gas, it recover it, it drive a compressor. Sometime in your applied thermal class, you also learn that it can generate electricity. That's how a gas turbine works. It's used to generate electricity actually. Okay, so these are the two components that you'll be looking at, and you are going to look at the thermodynamic performance of it. And just a bit more information for you, there are typically two categories of, we call this turbo machine actually, turbine and compressor. Okay, so there are two categories of turbo machine. It depends on how the flow across them. Either axially, it'll be called axial flow, turbo machine, or if it flow radially, it is called a radial turbo machine. Okay, so it's the direction of the flow. And the later one, the second one, the radial flow, is usually used in the small scale application, such as in the internal combustion engine rather than the power plant. Power plant generally is larger, so most of the time we're using the axial flow turbo machine. So the smaller one used in the smaller application, sometimes people refer it as a turbocharger as well. Something that you probably hear more often in a car. Okay, so they are both the same thing. They do the same job, and there is definitely a performance parameter for this machine. So anyone still remember the calculation for an open gas turbine cycle? What kind of parameter usually you will encounter when calculating for gas turbine cycle, specifically related to compressor and turbine. One guy say heat capacity. Heat capacity is not a performance of any component. Heat capacity is the property of the working fluid. Okay, so it's not a performance. Enthalpy, okay, kind of correct. Anything else you can think of? TS diagram, okay. Efficiency, right? So when we talk about the performance of a certain machine, efficiency is usually one of it. The more efficient your machine is, the better it operates. So efficiency is one of the performance parameter, okay, but not the only. So in this lab module, okay, I'm not going to go tell you exactly what performance you need to look for, because that's your task, your job actually to find out. So in this module, just remember the main goal is to evaluate the performance of a compressor and a turbine. They are one unit because they are connected together. The compressor is driven by the turbine. Okay. So you need to evaluate the performance of it. So, and you are required to find out the methodology that can achieve these three objectives. Okay, so let's look at these three objectives. What are they? So I already put down the objective here. In a way, this is the flow of this lab module you need to go through. So the first one, you must find out how someone define the performance of a compressor and a turbine. Any compressor, any turbine, the way we define the performance is the same. Someone already have an answer just now. Efficiency, okay. Efficiency, like I say, there's only one performance parameter. So find out how one would define it. Okay, because only then you can go to the next one, which is to find out the methodology one would use to evaluate the thermodynamic performance. So if you already have a parameter, you know which parameter you want to find out, you know what parameter you need to measure from the actual machine. Only then you can conduct an experiment. You collect the data. In fact, that's the data will be given to you later on. Okay, I can tell you what the data is. It's basically pressure, temperature, and mass flow. Okay, but exactly what parameter you need to calculate, where are they located, you must know. Okay, otherwise you wouldn't know what to do with the data as well. So once you know what performance parameter we're talking about, then you need to know how one would test these two components, these two machines, for the performance. Only then the result makes sense for you. And last, if you know all these two, both of these, it shouldn't be a problem for you to calculate the performance. Okay. I will give you one hint though. The performance of machine of these two, compressor and turbine, okay, in your applied thermal class, usually they are given to you. So it's a given information. Okay, so just a hint, just like efficiency, usually the question will tell you, assuming the efficiency of turbine has a certain value, right? So in the typical cost question, performance like this are usually given to you. Okay, but it is in reality something need to be measured only then someone will know that's the efficiency we're talking about, or that's the performance we're talking about. Okay. And following that line of thought, for instance, the efficiency, okay, usually in your applied thermal class, for instance, okay, efficiency is given as a value. It's a constant value, okay. But machine like this, most of the time they don't operate at one single operating condition. So which means this performance actually will change with certain variable. What are those variables? Okay, so if there's only one value, it's called point, right? Obviously, you only have one value. If we have multiple points, it forms a performance line. It's not a performance point anymore. Multiple line together, it forms a performance map. Okay, so machine like this, compressor, pump, or turbine, or expander, name it, even hydraulic turbine that you learn in fluid dynamics, their performance are usually defined in a map. It's a range of operating conditions. Okay, so those are the hints that I can give you for now. So your job is, at least by the Wednesday after the mid-sem break, you should find out what performance that we are talking about and the methodology of evaluating this performance, so that when I pass you guys the experiment data, you know what to do with it. Okay? Any questions so far? All right, should be clear. Okay, great then. So, yep, so the last thing I want to remind you is the full report is submit on the week of 25th. 25th is a Wednesday, so I believe the due date for submission should be on before the midnight of 26th. Okay, so these three objectives. So in fact, that is all that I would like to review through. It's literally just to give you a task, letting you know what you need to do, and it's your job to find out the information. So definitely find out how compressor and turbine works. Otherwise, you wouldn't know what kind of performance we're talking about. Okay, so once you know, you get the objective one, you need to find out the methodology. Okay, so that's the first task you have for today. Okay, all right then. So last time I'm going to ask any question? Anything anyone want to ask about anything?
Doctor,
Yep.
this is a group report, right? Or
I believe submission still individual. You can do it in group. You can
ah
do a discussion in group, no problem. But
okay.
submission individual.
Oh, okay. Thank you.
Any more?
Doctor, report in handwriting or we can do on Microsoft Word.
Up to you. I would say soft copy. Since you are going to submit in soft copy, why do you need to write by hand?
All right, Doctor. Thank you.
But either way, it's okay.
All right.
Doctor, so since this we can just discuss with our group members,
Mhm.
the methodology, can it be different or it should be the same in our
As
group?
far as I know, there's only one method to evaluate the performance of turbo machine.
Oh,
So
okay.
even different group eventually will
Be the same.
should be.
Okay.
Okay, but that doesn't mean that asking you to copy from other group. Yeah?
Bagi satu group satu report atau seorang satu report?
Sorry, say again.
Satu group satu report atau
Individual.
individual?
Seorang satu. Okay, right. So if no more question, then I will just leave you guys to start looking for information. Okay, right. So thank you very much. That is all from me. And don't forget your attendance in the group. Okay, so all right. So thanks very much.